Hi everyone, let's carry on with part 2 of our lesson on pressure. Now in part 1, we look at how pressure is used in our everyday life, and in part 2, we'll focus on doing calculation. Let's recall, this is the formula to calculate pressure, force over area. And again, to recall, the unit for pressure is in Pascal or Newton per square meters. The unit for force is in newtons, and the contact area is square meters. So with this formula, let's carry on to try out some calculation questions. But before that, let's take a look at something that you should take note of. Now, the formula of pressure is force over area. However, not all questions will tell you what is the force that's been applied. More often, you will see an object that is being placed on the ground, or you are holding on to something. Now, in that case, the force that is used in this formula will be equals to the weight of the object, because the weight is actually pulling, is the gravitational force that's pulling the object downwards. So in this case, you can use the weight as the force in the formula. So let's look at the first question. A book exerts a force of 10 newtons on the table. The contact area of the book with the table is 0.5 square meters. Again, the pressure is only exerted on the area which is in contact, where the two objects are in contact. And what is the pressure exerted by the book on the table? Now, remember the 3 steps that we take to do any calculation question. The step 1, you should always quote the formula. Step 2, you got to show the substitution. And step 3, of course, you give your answer. Please make sure you have unit. And the answer is given to 3 significant figure. A reminder again, do not give your answer in fraction. So in this case, the force is identified, the contact area is identified, so we will write the formula. Pressure is force over area, 10 divided by 0.5 square meters, and then you get 20 Pascal. But of course, you can also give your answer as 20 newtons per square meters. This is correct. This is also correct. Let's move on. In this case, this woman has a weight of 500 newtons. So note that if the weight is 500 newtons, that means this woman, the force that's pulling this woman down is 500 newtons. So the force in this case is the weight of the woman. And her shoes have a contact area of 0.02 square meters with the ground. So how much pressure is the woman exerting on the floor? Now, in this case, again, step 1 is formula. So we have the formula written, and then we substitute. The force is the weight of the woman, and the contact area of the shoes with the ground is given a question as well. And it is also a good practice for you to write unit even in this stage, although it is not compulsory, but it will be good for you to write the units here, because after you have written the units, you can see that if you have forgotten that Pascal is the unit for pressure, you will still know that you can write the unit as newtons per square meters, because you are taking 500 newtons and you divide by 0.002 square meters. So the unit can also be given as 250,000 Newton per square meters. And then they ask, how can this woman exert less pressure on the floor? Now we know that pressure depends on force and area. There's no way we can ask the woman to decrease her weight. So what you can then do is to increase the area, because if you want to reduce, okay, so if you want to reduce pressure, what you can do is you increase the contact area. So in this case, this woman is standing with only one foot on the ground. So you can ask this woman to stand with both feet, or you can also wear, of course, flats rather than um, the stiletto. Now, if you look at the diagram closely, this woman is actually carrying a handbag, and there's something else that looks like a file. Of course, if you want to exert less pressure, you in this case you can't reduce the weight of the woman, but you can let go of these items. That's another possible answer as well. Now, the next question, this is a very common question that you will see. A rectangular box, and the dimensions of the box has been given in this question. So this side is this side is 40, this is 20, and then this is 30. So the question asks for the maximum and the minimum pressure. So again, we know that pressure is inversely proportional to area. So when you want the maximum pressure, you want a big pressure, maximum, then you must make sure that in this case, the contact area is the minimum. Similarly, if you want the least pressure, minimum pressure, then your contact area has to be the maximum. So if you want a minimum contact area, then you will let the box, so minimum contact area, I'll use the green color. So minimum contact area is this one here. Okay, because this area is the smallest. So if you let the box rest on this side, you tilt it such that it rests on this side, then your pressure will be the biggest. If you want the smallest pressure, where you will need to have the largest contact area. So where is the largest contact area? It will be this face over here. So if your box is facing this, if this purple portion is facing downwards, then the pressure will be the least, because the weight is distributed over the biggest amount of area. So let's take a look at the answer. If you want to calculate, now before we do the calculation for pressure, it's important for us to convert the area to square meters. Now the units given, we have to be very sensitive to the units. The units are given in centimeters, but if we need our area to have the unit of square meters, then all this have to be converted to meters. So this will be 0.2, 0.3, 0.4, right? So the smallest contact area is this part here. So 0.2 times 0.3. So I've got the smallest contact area, and the weight no change, 50 divided by the smallest area, I will get the biggest pressure. Similarly, if I take the force, which is again 50 no change, and I divide it by the maximum contact area, so in this case the maximum contact area is this big face over here, so 0.12, then I will get a small pressure. So you notice from this question that we are talking about the same box over here, but depends on where and depends on how you orientate the box to rest on the ground. Depending on the area that is touching the ground, the pressure that's exerted is different. Now let's look at the last question. There are some people walking on eggs, and you're asked to explain why the eggs do not um, break. Now, again, let's highlight the word explain, and we ask ourselves, what is this topic about? This is about pressure. So, since we're going to explain pressure, I will then start by writing down the definition. I make sure that the definition for pressure is in my answer. So, let's read the answer. When a person steps on the whole tray of eggs, his weight is spread over a large contact area, or you can say it's distributed over a large contact area. So this is the keyword. That is a large contact area, because each time you are stepping on a few eggs, you're not just stepping on one, you're stepping on a few eggs. So the combined contact area can be quite large. And then you will support your answer with with a formula or definition. So you'll be here. Pressure is force per unit area. So write down the definition. So because it's force per unit area and your force is spread over a large area, then the pressure that you exert will be small. And because the pressure is small, the eggs will not break. Now this last bit here, okay, hence they will not break. This last bit here is actually linking back to the question. It makes the whole answer seem more complete. All right. So this is the end of the lessons on pressure. I hope you can understand. And if there's any question that you need to ask, please go back to your teacher and we'll be happy to help you.